Hello, my name is James Holland.
Hello, my name is Eduardo Farias.
Hello, my name is Ricardo Alta.
Hey, my name is Bruce Hicks.
And together, we're working on the autonomous golf cart project.
Hello, my name is James Holland. I'm a researcher here at Florida Poly, working with the Advanced Mobility Institute. For this project in particular, I'm responsible for establishing a means of communication between the golf cart and the website, in addition to collaborating with Bruce on the development of a drive-by-wire system to allow us to control the golf cart remotely. I just recently obtained my Bachelor's of Science in Computer Science and have continued my work at the university as I plan my next steps.
Hi everyone, I'm Eduardo Farias. I'm a student researcher working with AMI to develop a Ros Network and a simulation of the autonomous vehicle. I'm currently working remotely and located in Brazil.
Hello, my name is Ricardo Alta. I'm the software developer for the Autonomous Golf Cart project, and I'm currently working remotely from Brazil. I'm working on web integration with Matlab and with the actual golf cart, as well as developing the research website.
Hello, my name is Bruce Hicks, and I am a current student researcher at Florida Poly, working towards a bachelor's in electrical engineering. I am responsible for the control circuits for the drive motor, brakes, turn signals, and steering for the drive-by-wire system in the autonomous golf cart project.
In recent years, the buzz and novelty that once was associated with autonomous vehicles has been replaced with hope for an improved society ushered in by this cutting-edge technology. The optimism of AV technology has only increased due to the global pandemic. In a world that requires social distancing, efficient disinfection, and effective contact tracing, public transportation proves to be inadequate and a shortcoming. Buses, trains, and taxis effectively operate as incubators for infection. Imagine the impact that an autonomous fleet could have on public transportation, not just in these trying times, but also in the ordinary times that we wish to return to. Now that we've discussed the project, let's see it in action. On the left side of the screen is the control panel where a user can enter commands. In this case, forwards at 50% acceleration and reverse at the same rate. The golf cart slows to a complete stop before changing direction as per the motor controller design. In the right corner of the screen is the Raspberry Pi terminal, where we can see the commands printed to the screen, confirming that they were received by the server.
Hey, Ricardo here, and I'm going over the website I developed for the Autonomous Golf Cart project. Here's the homepage. You can go to the navigation bar. This is the About the project. It's a little introduction on why we did the project and why it's important to research that. Our team is people that worked on our team to develop this project, and a little bio describing what we do in the project. Sponsors and step-by-step documentation, we're still working on it, and apps. You can see all the apps we use to the simulation, also the languages that we use to develop the website. If you click on it, you can go to the official documentation. Let's log in. So as you can see, two new tabs open. The first one is Documents List. You can access all the documents that the group researched. You can click on it and view the actual documentation. If you want, you can choose a file and upload, and other people in the project can see. There's two simulations, the Matlab Simulation, the real simulation. So let's go to the real simulation. Here's the control I made. It's all in Python, so you can say forward and you choose 70. And the actual golf cart is going to receive this command. As you can see, I'm running the golf cart locally because I don't have the golf cart here. So it receives F70 and then the IP address that you connected from. The same goes for the steering angle, braking percentage, or if you want to click right turn signal, it also receives the actual data. The other thing I'm working on is an interactive control that you can play as if it was actually a simulation or a video game. So if I start to press up, the acceleration starts to increase. As you can see, it goes 0, 1, 2, and the same goes for braking. If you want to go for the steering, you can press right or left and it starts to change. As you can see, I'm now pressing left, it starts to change the steering angle. If I press left and up, the car starts moving and going to the left direction.
Hello, Eduardo here. So the main goal of a Ros network is to be a communication channel, and Ros networks are made of nodes. Each node can be a publisher, a subscriber, or both. Publishers are nodes that send information, while subscribers are nodes that receive information. In a really big network, it is important that the system is divided into different nodes and that each node has its own task or type of message that is going to be sent. For this simulation, we decided to use the Matlab app to be the interface between user and model. Other types of applications can also be connected to the Ros network. For example, we could also connect the website that Ricardo has developed. After the user then inputs the desired values for steering, acceleration, and braking, that information is sent through the Ros network to the model. In the model, it's possible to see subscriber blocks that get that information and pass it along to the vehicle model. Those values are then processed by the vehicle dynamics block set, and the motion resulting can be seen in the 3D simulation. In this example, we can see the car accelerating, then changing to the left side lane.
Hi, James again. Next, I'm going to briefly go over the server responsible for receiving commands from the website developed by Ricardo. This simple socket server runs on the Raspberry Pi and is bound to the IP address and port 1234. The client side of the website reaches out to the same IP address and port to send commands through. This is the first of two sections of code that handle communication with the Arduino that controls the golf cart. Here we open a serial port to send commands through and flush the input buffer to ensure that only clean data is coming through. Now with the setup out of the way, the server will continuously accept connection requests and commands from the client. These commands are then sent through the serial port to the Arduino to be acted on, here in the second of the two Arduino communication sections. Now, I'll hand it off to Bruce, who will go over the design and function of the golf cart control circuit.
Hey, it's Bruce again, and I'll be explaining how the golf cart handles commands. Basically, once the web app sends the command through the network to the Raspberry Pi will then forward that command to the Arduino to allow the Arduino to do most of the heavy lifting and the calculations for basic driving. The Arduino, in order to control the golf cart, it's actually utilizing most of the existing hardware that's already in the golf cart, such as the motor controller and the blinker circuit.
I wanted to thank you on behalf of our team for taking the time to learn more about our project. We hope to keep you updated on future progress and encourage you to visit our website. Thank you again, stay healthy, and stay safe.